second times derivative of the first. What's the derivative of 4 sine? Derivative of 4 times sine x. 4 cos x. Right? 4 cos x. Okay, now let's try to simplify a little bit. It looks like it's negative 4 sine squared plus 4 cos squared. There's a sine squared and a cos squared in there. It sounds promising at first. So negative 4 sine squared x plus 4 cos squared x. These multiple layers of derivatives, this one's simpler than the last. The first one is quite horrible. It takes a lot of practice to really see through each step properly, right? Even though the rules for each step are quite simple, but to get through the whole thing is not easy at first. All right, so negative 4 sine squared plus 4 cos squared. I cannot use a Pythagorean identity, right? What's the Pythagorean identity?
Sine squared plus cosine squared.
Why can I not use it? Because here sine squared is negative, right?
Yep.
So I can't use it. What do you say? Can't hear you. I'll take out the negative 4. If I take out the negative 4 from both of these, now this one's negative. So either way, one of them has a negative, no matter what I do.
Yep.
So I cannot apply a Pythagorean identity. And I don't even have to. All you need to do is plug in pi on 3 anyway, right?
Yeah.
So simplifying it down to its most basic form right now is not even that helpful. I just got to plug in the right value.
Yep.
Okay? So let's just go ahead and do that then. There is something you could do, but it's not worth it. Okay?
I would agree for sine of x would be 1/2, right?
Oh, let me write the notation. I'm going to write the notation. Y prime, get used to this as well, at pi on 3. Right? That's what
Wait,
I want to
I
find
have a
out.
question.
Yeah.
The line that we just found, that one is the negative 4 sine x squared, whatever.
Mhm.
That is the slope.
That is the slope of this function for any x you pick. Whatever x you pick, that expression will give you the slope of the original function. And we're picking pi on 3 for the particular location to find the slope.
Okay, isn't that the slope of prime then?
Slope
The
of
y
what?
prime?
No, y prime is the slope of y. That's what the prime means. The slope of that original thing.
Okay, thank you.
So I want to know y prime. I want to know the slope of y at pi on 3. So now I plug pi on 3 into our final expression over here. So equals negative 4 sine pi on 3 squared, where the square is going on the function, plus 4 cosine pi on 3, that quantity squared. Okay? Plug in the number, see what it is. Somebody was saying, what is sine pi on 3? What's sine pi on 3? Root 3 over 2. So we have root 3 on 2 squared, plus, if sine is root 3 on 2, it means cosine must be a half at that same location. Plus 4 times a half squared. There is the value of our derivative at pi on 3. But let's finish the computation. Root 3 on 2 squared is what? 3/4. But times 4 is going to cancel. So I'll just leave the 3. So it's negative 3 for this first, right? That expression is negative 3. And what's this one? 1/4. So plus, this expression is 1. So negative 3 plus 1 is negative 2. There's the slope at pi on 3. Yeah.
The 1 over x square, we apply the quotient rule. So the 4 sine x, are we supposed to apply the product rule? The 4 sine x, the first part.
This?
Yeah. Are we supposed to? Are we supposed to apply the product rule?
Yes.
So the 4 cosine x is the result of applying product rule?
Yes, that's right. First times derivative of the second. Derivative of cosine is negative sine. Plus, product rule is a plus, right?
I mean the first part is the separate 4 times sine x.
Oh,
so
do you have to apply
supposed
a product rule to that?
Yeah.
No, because this is the constant multiple rule. Remember, when it's a constant multiple, these are functions. These are variable functions.
But
It's a constant. So it just tags along the whole time.
But the 1 over x squared
over x squared.
we apply the quotient rule.
That's correct.
So for the 1 is constant.
Yeah,
Nevertheless, we apply the quotient rule.
that's correct.
So for sin x, so why not apply the product rule?
One is different because we have 1 over x squared, right? Where's the constant multiple there? There's no 1, but that just makes it itself. It is a constant multiple, but it doesn't do anything to anything. There's a constant multiple of 1 on this too. Not only that, there's infinitely many of them just floating around there, always times 1. So it doesn't influence it at all. Okay? The constant multiple rule is for non-units, non-ones. This whole thing is like taking the derivative of sin x cos x, multiplying by 4 afterwards. That's what the constant multiple rule is saying. And the same is true down here. I can factor off a 1 from this, right? So now it looks like this. I can take the derivative of this and multiply by 1 afterwards, and it's the same thing. Yeah? Okay.
Wait, I have a question.
I want to say one thing, since we said that I could take the 4 off. I did not take the 4 off the entire thing. You could. You can take the 4 off the whole thing, compute the derivative of sin x cos x, and multiply the 4 on afterwards. I chose not to do that. In general, I don't do that when I deal with product rule. I usually just associate the 4 with one of the 2 functions and call that first. I could have left the 4 off the whole thing and multiplied it at the end. Okay? But I usually choose to do it this way. And it really doesn't matter when you do it. It's up to you. But you definitely do not need to do a product rule here. Don't do it. It'll come out to be the same thing. But it's just wasting your time. Right? Because derivative of 4 is going to be 0. It's going to knock out half your expression. It'll come to the same thing, but it's not what you do with it. It would be like doing this. Flat. That's the same expression, and I can do the sum rule on this, but it's kind of a waste of time because I already know it's going to be 0 again. You know what I'm saying? All right.
Wait.
Yeah.
Okay.
So what's the question?
What is the negative 2?
What's the negative 2?
Yeah.
Negative 2 is y prime at pi on 3, which means it is the slope of the original function, this thing,
Yeah.
right when x hits pi on 3. Slope of curve at pi on 3. Negative 2 is the slope of this curve at pi on 3.
Okay.
Now that we have the slope of the curve at pi on 3, we need to find the equation of the tangent line at pi on 3. We have its slope, we just need to find the point. But what point does it have?
What are we looking for now?
That's the.
Say again?
What are we looking for now?
We're supposed to find the equation of the tangent line. But all we found right now is slope of tangent line, which is the same as the slope of the curve. Okay? So now we need to write it in y equals mx plus b form. We need to write the equation of the tangent line in that form. We have m. It's negative 2. Roger.
Would we use x? We give x as our.
You have to. That's the only thing you know about. All right? So when you put pi on 3 for x into the original function, that gives you a point on the original curve. That is the point that the tangent line shares with that curve. So it's also on the tangent line. So it's a point for both of them. And that's what you need. So you need to find out now what is y